Okay, perfect. Good afternoon. So, before I start, I want to say something. So much of you are asking me on private, like, when will we solve? When are the mock tests to solve? The IMAT is coming so soon. We have to start solving. I know, guys, you're stressing. I know, like, it's something so stressing because the IMAT is coming, and you really have to to start to, how we say, manage time, at the same time finish the course. So so I chose something to stop doing solving sessions now. Leave all the solving sessions for the end. Any question you have, try to ask it on private. Try to ask me it on private. Try to ask it on group. Like, we speak on chat, and let's use the timings of classes just to try to finish the course. So by this, we'll be able to finish the course fast, and we have to really start solving together. And so for today, we might do like the 2 hours of yesterday now, and the hour which is left for today. However, everything solving, we will leave it for the end. What does the end mean? Means after a week, we are done with the course. Less than a week, by less than a week, next week is the last week of course. After last week, it will be all solving. So, so guys, try, and if you see and if you notice that when I'm speaking in the course part, I'm speaking super fast in the slides. Why? Because I really want to finish the course so fast to start solving, you know. So, so I'll keep speaking fast. I guess all of you know this notes. Anything I feel like it's something weird or like not everyone know it, I'm speaking slower. Don't worry about this. And any question you have, leave it so we don't waste time on the Zoom meeting. So leave it for the private. Leave it for the group. Don't ask each questions. To be able to finish the course in this week, both of them, chemistry and physics, and to start solving by next week. So tomorrow you don't have tomorrow Saturday, Sunday. So on Saturday, Sunday, I want you to solve your assignments. I want you to make sure that you studied all of the slides that we already spoke about. You reviewed everything, and I want you to try to solve past papers by yourselves, of course, additional to the course that we're giving. And as I said, like everything solving, we leave it for the end. Now we have to focus to finish the course and end up with everything to start solving. So today we might do 3 hours. Okay. So first we will start by chemistry. Okay. So announce the principle of Pauli and the rule of Hahn. Okay, so we're gonna study about the electron configuration and the principles of Pauli and Hahn and everything like this. So the principle of Pauli says that in a polyelectronic atom, not more than 2 electrons are described by the same orbital function. They are characterized by the same values of quantum numbers, which we spoke about before, N, L, M, M, S, and And these electrons must have spin quantum m, and they must have opposite spin. Okay. So the Pauli principle says that in a polyelectronic atom, not more than two electrons are described by the same orbital function. Any orbital that we have or we draw for later in the chair electronic configuration, which is looks like this. So he's saying that each time you want to draw this electronic configuration, you must put on each one of these positions only two electrons. Each one can hold only two electrons. And he was saying that these orbitals that we're gonna have, they are characterized by the same values of the quantum numbers, which are n, l, m. And these electrons must have spin quantum, which is opposite to the other. Means if we have, let's say, lithium, okay, so it will have three electrons. How will they be divided? One, two. Let's say we have these two stages. We're not speaking, I'm trying to just give an example. We're not speaking perfect about anything. So so you put one first. If you have only two stages, okay, you fill the first stage, then you fill the second stage. However, if you still had one additional electron, you try to fill it in the first stage here, but you put the spin of it in the opposite direction. So it will be one going up, one going down, like this, like this. Okay. So in this way, we'll be able to fill the stages. We will take so much examples about them, so don't worry about this. Just know that Pauli principle speaks about that in one stage, you're gonna have only two electrons filled, nothing more. However, hand rule, the degenerate orbitals, okay, are first occupied individually by electrons, as we spoke about now, with parallel spin, and only subsequently by other electrons that pair with previous ones. So as we said, so the Pauli and Hand rule speak about the way of, of doing this electron configuration by putting first one electron, one electron, one electron, one electron, one electron. If we still had electrons, we're gonna put it in the opposite spin, like this. We might end up here, which is empty. Okay. Now describe the structure of the periodic table in base of the Aufbau method. So Aufbau method. So the Aufbau rule says that the ground state of an atom or ion, electrons fill the subshells of the lowest available energy. Then they fill subshells of higher energy. Keeping present the rules of Pauli and Hunt. Okay? So how is this, how are they speaking this way? So if you see any subshell, let's say we have SPDF. We said that before S only can hold 2, and then P can hold 5, 8 or 5, then 10, then 14. Guess 8. So if you see here, we have from the smallest to the highest, even in the KLMN. Since here he generalized, so even KLMN, we have 2, we have 8, 8, and here we have the rest. So if you see that here we start with the, I guess here it's 6. Let me just make sure. So for the IMAT, you should just know about these. So you don't have to go through the KLMN. So anyways, so if you see what he meant, yeah, 6. Okay, so if you see what he meant that each one of them from very high from a very low energy to the higher energy, they can hold the electrons. So this is the Aufbau rule. However, if we speak about each one of them, the S block, the P block, the D block, and the F block, we will reach a conclusion that the S block, okay, consists of 2 groups. Group 1, which is the alkali metals. Group 2, alkaline earth metals. Okay. So elements in these groups have their valence electrons in s orbital. The electrons in the s or are first to be filled by the Aufbau principle. Now, P block consists of group 13 to 18. And elements in these groups have valence in the p orbital. P is filled after s. The groups of 13 to 18 are non-metals, are metalloids, are noble gases. 3, we have the D block, transition metals. We have 4 the F block, which are the lanthanides, which are the last 2 rows if you see them in the end of the periodic table. So the lanthanides and the actinides. So these for memorizing. Okay. Now, within each block, elements are arranged in order of increasing atomic number from left to right. Elements of same period have same number of electron shells. Elements of same group have same valence electrons and same chemical property and same electron valence electron configuration. Okay. So, comment the property of the elements in different blocks of periodic table in function of their electron configuration. So let's speak about the S block itself. S block, as we said, is group 1 and the group 2. Group 1 elements have single valence electron. So let's speak about the group 1. Single valence electron. Okay? In the s orbital, they are highly reactive metals. They have low ionization energy and tendency for +1 cations. Okay. However, the P block, which are 13 to 18, so group 13 has an oxidation number. And the cations that they can make, that's 3 in the anion, 16 minus 2 ions, 17 minus 1 ions. 17 are highly reactive, which are the same halogens and halides, and they are strong. They have strong oxidizing property. Okay, noble gases are non-reactive. The D block, which are the transition metals, D block, they have very so the D block, they have very high melting point, boiling point. They are conductors, multivalent, whatever. And the F block, which are the lanthanides and the actinides. You're not asked about them for the IMAT, but I'm gonna speak about them. So the F block, we have the lanthanides plus actinides. So you should I think just you should know that they are in the F block. You should know that they are rare earth elements. You should know that actinides are radioactive. Valence 5F, complex elements. They have a use in nuclear applications. Okay. As I said, we're gonna take an example of the Hunt and Pauli rule. So let's say we have lithium, as we said. The electron configuration. Number 1 is to know the electron configuration. You should try to draw this. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 5f. No. 1 moment. Yeah. 4f and then whatever else, like 5 and whatever. So you do like this. So 1s2, 2s1. This is the electron configuration. We use these two. So how should we draw this as according to the Hunt and Pauli's rule? We put first the 1s and here the 2s, 1s and here the 2s. So first we have to fill according to 1 electron by 1 electron. So first you have to fill the first electron in the 1s, which is here. Okay. The second electron in 1s, okay, which is here, which is in the opposite spin, and the electron which is here in the 2s part have only 1 electron in the higher spin. Okay. Let's give another example. An A electron configuration is 1s2, 2s2, 2p6, 3s1. If you add these together, 6, 7, 8, 9, 10 will give you neon. So you can still write it Ne3s1, same. So how to draw this? First, we should put this levels. So we have 1s, we have 2s, we have 2p, we have 3s. Okay, so 1s, 2s, 2p, 3s. So then we put how much do we have in 1s? We have 2, 1 up, 1 down. Okay, into s we have 1 up, 1 down. In p we have 6. So how should we write them? Each one can hold only 2, so we should divide them in 3. 1, 2, 3. 1. How do we fill this 3? We fill them in this way. 1, 2, 3, 4, 5, 6. 1 should be filled, all of them should be filled in the up direction, and then we continue the down direction. Okay, and then we still have 3s1. We have 1 here, which is up. Okay, let's see who's speaking on chat. Size x, x, y, z form. What do you mean by this? Anyways, so let's give a last example. Yeah, you want to see like how do they look like? You're asking how does 2px look like and these things?
No, just divide it to 2px, 2py, 2pz. Each one can hold 2 electrons. I was saying this.
Ah, yeah. Are you trying to explain? Okay, okay.
It's the same. You are writing dash dash. It's same. No problem.
Yeah, it's the same. Thank you. Okay, now we're gonna speak about the K, which is the potassium. So the electron configuration of the K is 1s2, 2s2. Guys, you know how to write the electron configuration because I'm writing it without explaining. So if you don't know, just tell me. So 1s2, 2s2. I just drew here how you draw it and you fill it, you know. So P can only hold 6 to P6, 3s2, 3p6, and 4s1. Okay, so we have to first write these levels under each other. So 1s, 2s, 2p, 3s, 3p, 4s. We have 2 here, so it can only hold 2. We just put this one and this one. Here also can hold 2, this one and this one. Here we have 6, so we have to divide into 3. So 1, 2, 3, 4, 5, 6. 2 also 3s2, it can only hold 2. So 1, 2. And then also P will hold 6, which will be the same as the first one. So 1, 2, 3, 4, 5, no, to there, like this. Okay, 6, and the last one for S1, which is only going up. Okay, so this is how we draw it. Okay, describe the periodic properties of elements, the atomic radius, ionization energy. We spoke about all of these characters before. Let me see if there's anything additional in the book. So, no, nothing is additional. No, nothing is additional. Yeah, there's something additional. So we just will add something about electron affinity and continue to the others. So let's speak about the electron affinity. So the electron affinity as we spoke before, it's the energy change that occurs when electron is added to gaseous atom. When an electron is gained by an atom, this energy which is lost by this atom is called the electron affinity. So when we said energy change, this means the enthalpy change. But we speak about it in the thermodynamics of chemistry, which is the delta H. Okay, so the enthalpy change that results from addition of an electron to a gaseous atom can be positive or negative. Okay. Now, if we have the more the negative the value of this enthalpy, the value of enthalpy equals more stable anion. Because when we gain an electron means we are adding the negativity inside this atom, inside this electron shells. When we add it, this atom becomes an anion. Okay. So let's say that we have the electron affinity positive. This means that this reaction is exothermic, means delta H negative. The enthalpy change is negative. And when we have electron affinity negative, the reaction will be endothermic, means the delta H or the enthalpy will be positive. Here the reaction is spontaneous, here the reaction is non-spontaneous. Okay.
Ma'am, there is
Yeah.
confusion. I think you are making some mistake. Exothermic is negative, I think. And
Yeah.
endothermic is positive
Yeah. Delta H is negative.
for exothermic, right?
Exothermic delta H is negative. Endothermic delta H is positive.
Okay, okay.
Okay. So when the electron affinity increases, the enthalpy will become more negative. When the electron affinity decreases, no. When the electron affinity decreases, okay, the enthalpy change will become more negative. I think you thought that I'm doing a mistake because because when you see negative, you are saying that it will be exothermic. No, it depends in thermodynamics. It just depends on the enthalpy and on the Gibbs energy, free energy. So when delta G is negative and delta H is negative and the entropy delta S is positive, this means exothermic. Nothing to do with the electron affinity. Electron affinity is the complete opposite of the enthalpy, you know? It's like there is a negative, how we say, negative relation between them, opposite relation between them. Yeah. Okay. So no, electron affinity is not always exothermic. It can be endothermic. I think for the IMAT you should know it just for exothermic, but I'm using, as I said, it's a chemistry first year in Italy. So maybe I guess for the basic level they are asking for only exothermic. Why? Because it's it's releasing energy because of gaining an electron. I guess later you should know about why is it endothermic, not in this level. So like if you want, you can just memorize about exothermic, but like you just put in mind it might be endothermic. So now we will speak about the 3D geometry and the Lewis structure of the atoms, of the molecules. So does anyone of you know about like the how to draw the root structure? I guess yes. But do you know how to write the 3D geometry? Like what is the shape of this? What's the shape of this? Does anyone like know about it or no? About yeah, exactly. Yeah. I'm asking if you know the how we say these ones which are the bend shape, the linear shape, the trigonal planar, trigonal pyramidal, these ones. Perfect. Okay, perfect, guys. Good base. Bravo. Okay, so first, I want to make sure that these definitions, you know them. So let me just say, write this definition before I continue. So define the latest energy of ionic solids. Okay. Latest energy is the energy that is released in the formation of 1 mole of solid. Okay. Starting from the ions isolated in the gaseous state. Okay. Okay, this. If we have more than 30 electrons, do we write 3D first or 4s first in configuration? I think I taught you how to do it. You start with the 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f. Okay, you do like this. Okay. Okay, so what was your question? 3D or 4s before? Okay, so you do like this. 4s before. 3p is with 4s. 3D comes after 4s. Look. So try to memorize this way, you know? It's much easier than to memorize this before or this after. Okay. So the latest energy of ionic solids is the energy that is released in the formation of 1 mole of solid starting from the ions isolated in the gaseous state. Let's take an example, NaCl, starting from the ions Na plus and Cl minus, and ending up in the NaCl. So the energy which is released is called the latest energy. There's something that's called negative latest energy. I don't know, this might come, this might not come, I don't know. But let's speak about it. So negative latest energy. Okay. It's the energy that must be supplied to push away all the ions of 1 mole of solid. So the energy to infinity in gaseous state. Okay. So these definitions, guys, you should really know them because in IMAT sometimes some basic things which we think that we know them, they might be asked as definitions. So I try as much as I can to give definitions the way that they give them, like the exact word by word, by the same word that they give them, because like the options might be so similar and they just change by word. So when you memorize the definition by heart, it will be like so easy on you. Now let's give some things you should know about the latest energy. So if we have very high charge of ions, we're gonna have high latest energy. It's so normal. Why? Because we said that energy which is released starting from the ions. Okay. This means that we're gonna have a low distance between them. This means we're gonna have low dimensions. Okay. 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 We spoke before about, okay. This is okay. So high charge of ions, high latest energy, low distance between these ions, and low dimension. Now, what is electronegativity? Is a chemical property that describes the tendency of an atom or a functional group to attract electrons toward the cell. Now, let's go for the Lewis structure. What is the Lewis structure of nitrate? Oh, before this, I want to speak sometime about the polyatomic ions. Okay, so I made a small summary about the polyatomic ions that almost have them all. So let me write them all. Okay. So H2PO4 minus. So these are the polyatomic ions. This is dihydrogen phosphate. Okay. C2H3O2 minus. This is acetate ion. We have hydrogen sulfide, HSO3 minus. Hydrogen carbonate, HCO3 minus. Nitrite, NO2 minus. Nitrate. I will give you now a way to memorize them. NO3 minus. Cyanide, Cn minus. Hydroxide, OH minus. Permanganate, MnO4 minus. Hypochlorite, T not D. Okay, hypochlorite, Cl minus. Chlorite, ClO2 minus. Okay. chlorate, ClO3 minus, perchlorate, ClO4 minus, hydrogen phosphate, not dihydrogen, hydrogen. Just take one hydrogen, so HPO4 2 minus, oxalate, C2O4 2 minus, sulfide, SO3 2 minus, sulfate, SO4 2 minus, and then I will teach you a way, don't worry. Just I'm trying to write them, so you write them with me or you take screenshot, but like I'll teach you a very, very easy way to memorize them also easy. So sulfate, SO4 2 minus, carbonate, CO3 2 minus, chromate, CrO4 2 minus, dichromate, Cr2O7 2 minus, silicate, SiO3 2 minus, phosphide, PO3 3 minus, phosphate, PO4 3 minus, ammonium, NH4 plus. However, everything else for covalent bonds, we have one means mono, two, di, three, tri, whatever, tetra, penta, hexa, hepta, octa, nonna, deca, this. Okay. Oh, we still have, okay, let's continue. We still have. Okay, so acetic acid, H4, C2O2, carbonic acid, H2CO3, hypochloric acid, HCl, nitric acid, HNO3, phosphoric acid, H3PO4, and that's all. Okay. Okay, perfect. So, way to memorize the important ones for the IMAT, and a way that I memorize the important ones for the IMAT is this way. So I tried to do something. I don't want you guys to laugh, but it was the only way that I was able to memorize. So I don't know. I'm shy to say it, but it's okay. So I memorized in a way that, okay, New York City, so MC, and then chromium here, and then SP, okay, and then I put them in a way that here we have a 3 over 2, and here we have 4 over 3. So 3, 4. Okay, and then you do minus 1, here you do minus 1. Everything with the 8 is here, is the bigger one. Everything with the 8 is that one. And then here, let's say you want nitrate NO3 minus. Okay, carbonate CO3. Yeah, and let me also teach you about the charges. I didn't finish. So the charges, here you have 1, here you have 2, 2, 2, 3. So I have 3 twos inside and one here and one here. So how I wrote them? NO3 minus, because here we have 1. CO3, 2 minus. CrO4, 2 minus, because here we have 4. SO4, 2 minus. PO4, 3 minus. This is phosphate. However, NO2 minus. This is nitrite. So in this way, I memorized them. You can even, if you want, you can add here the chlorine. Put here 1. And here another chlorine, because there's so much chlorine. But I think these. Now, what did I use this chart also for? To know which one of them is acidic, which one of them is basic. So I drew in a way, when we reach the acidity and neutrality and basicity, I'm gonna teach you on this. So it's so easy, just like NC, CRSP. Here you put 3, here you put 4, and then you put here 1, 2, 2, 2, 3, and you have them all here. Here you do minus 1, here you do 3. I don't know. In this way, I drew it in the IMAT and I was working. Okay. So we were speaking about the Lewis structure. So Sayed, I don't understand what's okay. Look, you didn't understand. You don't have to go with this. Try to memorize them. You understand? Like, I don't know. Like for me, it worked. I don't think it will work for no one. It's okay, Yani. It's okay. Try to memorize them, Sayed. So let's draw the Lewis structure of nitrate. As we said that nitrate is NO3 minus. So how do we draw the Lewis structure? Okay. First, we draw the inside atom, and we see the valence electrons, which is N, the least one. And then we put here N has 5 valence electrons. So 1, 2, 3, 4, 5. And then you put the oxygens around it. 1, 2, 3. Oxygen has 6 valence electrons. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then you bond them together. Here you will end up, you still have 1, 2. So you put this up. And here you're going to have 1, 1, 1. What happens here? This one that we have here is going to bind with this. Why? Because they have something called the resonance. No, later the resonance. Now we're going to bind these two together to form a double bond. So here we will have a double bond. Okay. And here we will have, we're going to have here 1. And here another 1. And here we will have also 1. 1, 2, 3, 4, 5. Here 1, not 2. Okay. So you have 3 options. You have either to calculate the formal charge and to do it, or you have to it's either you calculate the formal charge and you do it, or you have to try to do it in a resonance way, in a way in your mind, you know. So for me, I try to do it in a way in my mind. However, if you want to calculate the formal charge, it will be here 5 minus 2 minus 3 over 2. It will be 1.5 for n, and it will be 0.5 for oxygen. Each one of them will be 0.5. And then you will find that N has a higher formal charge. This means that N can donate for one of them an electron. So then it donates this electron. So what happens here? It will donate this electron to here. So it will be 1, 2, 3. And then it will also donate an electron to here. It will be like this. So that it will end up the Lewis structure in this way.
There is no lone pair, right?
Huh?
There is no lone pair.
I didn't understand.
Is there any lone pair? I mean, without bonding?
No, no, no lone pairs. Exactly, bravo. So here we have like this. Here's gonna be like this. No lone pairs. So this will be the Lewis structure. You can solve it in a resonance way to see how the resonance can work, or you can also solve it in a way to solve or to calculate the formal charge. At the end, it goes to you. Okay, so since we don't have lone pairs, this will give us a what kind of shape? It will give us a band shape as geometrical structure, or it can also be trigonal planar, one of them. Okay, and the angle which is between them is 134.3 degrees. You can say trigonal planar, but like it is slightly bent shape, slightly bent. Okay. Now, texting. Oh, okay. Okay, guys, let's take a 5 minutes break, and then we continue. What time is it now? Okay, it's an hour. Perfect. So
Make
5 minutes
make it
break. Yeah,
make it
10.
10 minutes because I want to pray. Make it
10
10 minute
minutes?
break. Yeah, yeah.
Okay. Take a
We
break.
will pray also.
Who are you?
Oh,
Who are you? Who's talking?
I'm sad.
Sad. Okay, sad. Take a break as much as you want.
No, I want to pray, Isha pray.
Want to pray? تقبل
Yeah, yeah.
الله. يلا go.
Oh,
Okay, hello guys again. Okay. Okay, so not Saad. Sayed was asking about the formal charge and how it can be calculated. So let me just share. Okay. So yes, Sayed, it's just a formula, you should know it. So the formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Okay. Let me give an example. Let's say we have, let's go to an easy one. Okay. Let's say we have water, H2O. Okay. So oxygen 1, 2, 3, 4, 5, 6, and H1 and H1, bond. Here we have two lone pairs. So how can we know the formal charge of oxygen and the formal charge of each hydrogen inside this structure? So let's start with the oxygen. Oxygen has valence electron 6 and have two covalent bonds with hydrogen. So these are the bonding, and has two lone pairs, which are the non-bonding. So 6 minus 2 which are the non-bonding electrons, minus half times 2 equals 6 minus 2 minus 2 minus 1 equals to 3. So the formal charge of oxygen in this water molecule is 3. Okay, so the K and half times the bonding electrons. Okay. If we calculate the ones of this is oxygen. Now the hydrogen. The hydrogen has one valence electron, has zero lone pairs, and have minus half one. Have only one bonding, so minus half. It will give a 0.5 formal charge. So if oxygen is 3, hydrogen is half, hydrogen is half. So if you want to do anything here in the resonance, we work on the oxygen. Why? Because oxygen has the highest formal charge. This helps in the resonance. When you have the formal charge, will help you in the resonance. Let's say we have here, let's say we don't have 2 here, we have only 1 here, okay? And let's say we have, let's say another element that has also 1 lone pair here. And this element has a very low formal charge, and this element has a very high formal charge. So you do a comparison. You be like, okay, this has a higher formal charge than the second one. So this one will go here instead of this one to go here. You know? So you take the lone pair of the higher formal charge to the other side, to the smaller. You know how you use it? Like just in this way. Yeah. Let me do another example about the structure. Let's say we have sulfate ion. So sulfate is SO4, 2 minus. So we draw it as S is like oxygen because both of them are in the same group. So S is 6 also, 1, 2, 3, 4, 5, 6. We have 4 oxygens here around it. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. These two, one, these two, one, this one, this one, this one, this one, this one. Now we bond them. So here one, it will end up only one out. Here one, here will end up only one. Here one, so and here one. Okay. Now let's see the formal charges. If you want, guys, you can see them. If you don't want, you just do them according to your mind. Let's do them. Let's stay on the safe side. So the formal charge of each oxygen here will be 0.5, 0.5, 0.5, 0.5. And the sulfur will be 2. Yeah, plus there's something that this oxygen will make a double bond here. So this will go. So now we have a double bond. And also this one will make a double bond here. Okay, so here also will make a double bond. So because sulfur is 6, so 1, 2, 3, 4, 5, 6. Yeah, it contained the octet. It finished the octet. Now we will end up, this one have nothing, this one have nothing, and these here we have 2. So what will we do with this 2? If you see S don't have any more lone pairs, this one don't have any more lone pairs, this one have no lone pairs again. So according to resonance, now we should not care really about the formal charge, now we should care about the ion. So 2 minus means it gained 2 electrons. Gain 2 electrons means it will be divided, here 1 and here 1. And This is the Lewis structure, so it will look like this. So, okay, and then this one. Okay, what is the shape? We have no lone pairs and we have four elements around it, so this is tetrahedral shape. Okay. Um, okay. Let's give another example. Before anything, let me make sure the chat. Do NO3 minus what? NO3 minus. We did it. We already did NO3 minus. You want me to repeat it? Okay, let's repeat it. What did you say? By formula S is having 3 charge. You mean the three is for the charge or as subscript down for the oxygen? Formal charge of S is 3. No, 2 minus 4 SO4 2 minus, yeah. 2 minus 4 over 2 will give it 2. 2 minus 4 over 2, you multiply by 2, you multiply by 2, 4 minus 4 over 2 will give, yeah, there's a 0 lone pairs. Let me make sure what you're saying. Okay, let me draw again the SO4. It was looking like this, S. Okay, you want me to calculate the one of S. How much is the valence electrons of S6? And how much is the non-bonding electrons? 0 minus half times the bonding. We have 1, 2, 3, 4, 5, 6. Okay. Minus half times 6, I mean. So 6 minus 0, 6. 6 minus... bravo, Said. Yeah, exactly. Yeah, you know what? What was the wrong thing is I put here 2 instead of... because firstly, I drew it in a way which before when I was preparing for the session, I drew it in a way that I put these 2 instead of giving them here, I put them here. So that's why I chose that it has 2 lone pairs. But then like after I did it again, I found out like it's 2. So I stayed on the old one. So yeah, it's 3. And you think in NO3, even N has 1.5. Let me see what he's saying. 1 formal charge. Let me draw NO3 again. Okay, so NO3, it was looking like this. Okay. So how much is the non-bonding? 0. The bonding are 4. How is this? The non-bonding ones are, the bonding ones are 1, 2, 3, 4. Okay, so there are 4. Mm,
Ma'am, you multiply by 4. This 4 is bonding pair or
4 is bonding because it bonded, look, 1. If you see here, 1, 2, 3, 4. It have only double bond with this. It doesn't have no lone pairs, and it has here 1 and here 1. So it's only 4. Yeah, it ends up 3, but it stays like higher than the oxygen, you know.
one thing
Okay.
I want to ask, is this important formal charge to calculate formal charge?
To be honest, no. But Said is asking how to calculate it, and he's trying to work as a rule instead of working like as thinking, you know. So to be honest, I stay on his side in this. If you're able to calculate it so fast in the IMAT and stay on the safe side and know how to take the resonance and electron from which side to the other, I think this is the best way to think of it. However, if your hand got like used to this, you will know how to do it. Like me myself, I don't calculate the formal charge. Like I just do it, you know. So at the end, in the end, it just depends on the person. Lewis structure, it was not important for the IMAT before. It's getting important. I'm not knowing why. Before, like, if you see the old ones, chemistry used to be so basic in the old sessions. However, in the upcoming sessions, chemistry is becoming more hard. Those structures being asked, not just in the English one, even in the Italian one, they also are asking about the Lewis charge. I'm not knowing why they are making it harder. However, I think they should have made it the same level. Like, okay, before, let's say a person is memorizing or is practicing on the level of the old past papers. And then they come and they bring a higher level. Then you repeat the exam and you study for the higher level. And then they bring a higher level than the higher level. And then you have to repeat the exam again and study for the higher level. And they're always higher with the level. So that's why I'm trying to give you the higher level. However, I didn't see any question about this, to be honest, in the IMAT. But it's coming on the talk and it's not even written in the syllabus. So I'm not understanding what should we do for this. Okay. And there's why I'm saying this, because it's a kind of system that no one knows what to study. No one knows what to do, how to deal with their minds, you know? Knowledge never goes to waste. Exactly, 100%. Exactly. Okay, let's do sulfite. So SO3 2 minus. So it will be like S, and we have a 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Bond, bond, bond. Okay. So SO3 2 minus. Yeah, before I guess we didn't say the shape. No, tetrahedron. Okay. Okay, now start fine. So here we will have one, we still have here a lone pair, and here we have one. So we make them a double bond so easy. So now we have another bond. And here we have one, here we have one, we have 2 minus, we put one here, and we put one here, we're done with this. So it looks like this. Okay, now here double bond, here, 1, 2, 3, 1, 2, 3, 1, 2. And the shape of it is, do we still have lone pairs? One, two, three, four,
Yes, one lone pair
five.
because it is gain two electrons.
Still have one lone pair, exactly. Okay. And what else? Okay, that's all. Perfect. So, what do you think the shape of this? Of course, like in real life, it does not look like this. It looks like this.
Bipyramidal?
Bipyramidal. Not bipyramidal, it's pyramidal. Let me teach you a way to know them. A very easy way. So first we have um, linear and bent. The one that have lone pairs is bent. We have planar and pyramidal. The one that have here, of course, it looks like this. Here it looks like this, and here it looks, and of course we're saying lone on the central one, you know. So planar and pyramidal. Pyramidal has the lone. Tetrahedral and bipyramidal. Bipyramidal is the lone. Okay. So when you see five atoms like this, A, B, C, D, E, this is tetrahedral. The moment it has here a lone pair, the central one, it's bipyramidal. The moment you see A and having three around it, so B, C, D, the moment it has a lone pair, it's no more planar, it's not trigonal planar, it's trigonal pyramidal. The moment you see 1, 2, 3, okay, the moment it has a lone pair here in the middle, it's a band, it's not a linear. It does not have it's a linear. It does not have it's a planar. It does not have it's a tetrahedral. Yeah. Okay. So here we were saying that it looks like this. So it was SO3 2 minus. It had a lone pair here. So this is pyramidal because it has three. So this means it's trigonal planar. We saw a lone pair, so it's pyramidal. Okay. If it was tetrahedral, if it had something here, and it also had above all of this, it has a lone pair. This is bipyramidal. However, it does not have nothing up, so it's a pyramidal. Okay. Ammonia. NH3. N, H, H, H. N has 5. So H has 1, 1, 1. Still had a lone pair. One lone pair, I mean. Okay. So, one lone electron. So this is trigonal. What do you think, guys? Wait, 1, 2, 3, 4, 5. Ah, here it has 2. Yeah, looks like this. Okay. So this looks like pyramidal, bravo. So it's trigonal pyramidal, and it's 107 degrees. 107.7, I guess. Okay. Some books say it's tetrahedral. I tell you why some books say it's tetrahedral, because these lone pairs make a repulsion, and it does not have only one electron, it has two electrons. So these two, they make resonance, and this resonance will act like a full element, and it will act like this. Imagine. So when it acts like this, it will be a tetrahedral. So some books say it's a tetrahedral and the others say it's trigonal pyramidal. Me myself, I say it's trigonal pyramidal. However, when I did my exam at the university, they considered it a tetrahedral, not trigonal pyramidal. I don't know why. Okay, so carbonate. CO3 to minus. So carbon has 4, oxygen 1, 2, 3, 4, 5, 6. Okay, bond, bond, bond. Okay, okay. So we have here one additional one. So of course we make it a double bond first. Always double bond has a priority. And then we see the resonance, the formal charge, whatever, okay? So then, yeah, we have one double bond, which is this. This is no more there, so we delete this also. And then we're gonna have here O and here we'll have 1. So we have 2 minus, we add here 1, we add here 1, and it will look like this. 2, 3, 1. No, it's 3. I'm sorry, guys. So here 1, 2. Okay. So what do you think the shape of this? Let's see if you guys know. Shape of, I know I drew it in a very confusing way, but it's okay.
Triangular.
Diagonal what?
Pyramidal.
Why pyramidal?
Oh, no, sorry, sorry. This is triangular planar, I think.
Yeah, because there's no lone pairs on this way. Do you see here lone pairs? No lone pairs, so it's diagonal planar, not pyramidal. Okay. 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 Now let's give Saad and Sayed the very hard one. Let's see if you will know it. I want you guys to put a paper and the pen and try to do this. Let's see who will. And I want you to give me what is the name. Okay, and then we will solve it together on the board. Just I want to give you some time to try to solve them and to make your hand know how to solve them. So tin chloride, SnCl2. Yalla, do it and tell me what's the geometrical shape. All of you, yalla. Yalla, do this, all of you. Let's see what's the shape that you will end up with it. Yalla. Tin chloride. Tin is Sn, guys. Okay. Sn is the same group of carbon. It's under carbon by 2 elements. So this means it has the same valence electrons of carbon, so it's 4. 4 valence electrons. Trigonal pyramidal. Okay. Who else? Who else? Trigonal pyramidal. So humor said trigonal pyramidal. Do you think, guys, it's correct? Okay. Bravo, Angela. What else? Let's see. So chlorine is in the halogens, has 7 valence electrons, and Fn has 4.
In my opinion, it is bent with one lone pair.
Okay. So who gave correct answer is Ifra, Angela, and the Humera. And who's the one who talks? Sad. Okay. So yeah, Sad. Sad, I always forget your name. Okay. So SnCl2. Let's do it. So Sn is 4, Cl is 7, Cl is 7. Tick, tick, tick. Okay. So here we have a 2. They do resonance. Okay. And here we're gonna have, yeah, that's all. Okay. So if you look at it, you will see, you'll be like, okay, it has 3. It might be either linear or bent, right? But so if you said bent, it's correct. Why? Because it has a lone pair. However, these two here, they will make um, a resonance, and they will be considered as one full element. So when they are considered of one as a one full element, it will be trigonal pyramidal. Okay. Now the most, how we say, the most logical one is bent. Some books write trigonal pyramidal is also correct. So Humera, you are also correct. Okay. Now let's give a harder one.
One question, ma'am. Uh, Up to how many atoms should we memorize? Because I struggle with the electronic configuration of SN.
Um, you mean up to how many elements in the same molecule you have to memorize? Five. Five
Yes,
maximum.
yes.
5 maximum. Okay. Let me give you the harder one. Like I'll give you the hardest one you might see in the whole chemistry. So is this. Yeah, try to solve this, guys. Okay. So sulfur is the same group of oxygen. This means it has 6. Fluorine is the group of halogens and halides. It has 7. Try to do this. Now, if you're able to solve this, this means that you're able to solve them all, because this one of the hardest ones might come, which will never come. Bravo. The angle and the shape are the same, but you should memorize that trigonal planar is 120, linear is 180, and tetrahedral is 109.5, and yeah. Like the only ones that you should add them are the water angles and the ammonia angles. Here 104.5 degree, and here 107 degree. Yeah. Okay, perfect. So did anyone reach an answer? So he gave us an answer, Mr. Sayed tetrahedral. Okay, let's see other options. Might be correct, might not. So let's see the others if they agree. For bonding, one lone. For bonding, one lone. No, don't talk about seesaw, not seesaw and the things. I want to know the ones that I taught you. Tetrahedral, trigonal planar.
I think this is tetrahedral with one lone pair. One lone pair.
Huh?
Tetrahedral
Yeah, it
with
has
lone pair.
tetrahedral with lone pair. What does it give? I already spoke about this. Now, I explained it. Let me explain them again before we continue.
Pyramidal.
Guys, focus. Focus. So normal, lone. The normal one is linear. Its lone one is bent. The normal one is planar. Its lone one is pyramidal. The normal one is tetrahedral. The lone one of this tetrahedral is bipyramidal. So if you saw a tetrahedral having a lone, it's a bipyramidal. If you saw a planar having a lone, it's a pyramidal. If you saw a linear having a lone, it's a bent. This memorize it in this paper. Okay. So when we draw it, we're gonna have S, F, 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 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, tick, 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 tick. Okay, here also. 1, 2, 3, 4, 5, 6. We will end up like this here. So this will make a resonance. This is tetrahedral having a lone pair. It will end up a trigonal bipyramidal. Okay. I think bipyramidal is when all of the pairs are bonding. S is seesaw for
I
bonding
think this
one
is
lone.
pyramidal with one lone pair.
I think I think bipyramidal is when all of the pairs are bonding.
Yes, with no lone pair.
Okay, in the book it's written bipyramidal. Let me make sure from Google then. I don't think a book will make it wrong, so let's make sure now. Yeah, also it says yes, it's bipyramidal. No, it is bipyramidal. Everything here says it's a bipyramidal. Like it's an Italian book. I don't think Italian book will make a wrong, you know? Let's make sure again. Yeah, it is bipyramidal. SF4 is a bipyramidal. Yeah, but you're studying for an Italian exam, you know? If the book of Italy says this, and it's a book on the University of Parma, which is like you will study this when you enter, you know, this the general chemistry. You will study this when you enter medicine in English or in Italian. This book you will have it. So it says like this. So I don't know. Bipyramidal is when 5 pairs. I know this. I know this. I know that when I studied for the IMAT, I studied the same way. Bipyramidal is 5 bonding pairs, and 1 lone pair and 4 bonding is a seesaw. Exactly. But the book says this, so I'm teaching you from Italian book. If it was like anything else, like anyone who created the book, I would not like work with this book, you know. So it's okay, guys. I don't know what will the IMAT like take this in what kind of consideration, but I don't know, to be honest. I don't think this will come if an option given or seesaw. I don't know. I don't know. Don't ask me. I don't know. Seesaw or bipyramidal. Now, as a definition, seesaw have 4 bonding, 1 lone pair. Bipyramidal have 5 bonding pairs. Italian book says it's a bipyramidal. However, any other book would say it's a seesaw. So what should we do? Yeah, why did I choose Italian? Why I'm not teaching from Cambridge or whatever? Because if you're studying from the same country that you're studying the exam for, you will be always on the safe side, safer than you study from another book. So I don't know. It's okay. It's okay. Let's go over this. Uh, um, for this, I don't think it will come on the IMAT. I'm 100% sure this won't come. This topic itself doesn't come on the IMAT, as we said. We said it might come, but of course not this level, you know. So don't worry about it, Sayed. But to be honest, I don't know. If the book says this, I cannot say nothing, to be honest. And to be honest, like I'm teaching. Yeah, PCR5 is easier. To be honest, like if you just see PCR5, you compare PCR5, I guess PCR5 is so easy, to be honest. And especially they ask about this in a kind of way, which is about if this polar, this non-polar, you know, in this way, it's more than Lewis structure and geometry. Anyways, as I said, I'm teaching you from Italian book. I'm not teaching you from any other book. So it's written in Italian by Pyramidal in Italian. I'm translating for you guys, you know? It's written by Pyramidal. Anyways, on the IMAT, Lewis structure is not really asked. Most likely polarity, non-polarity are asked more than Lewis structure. So it's okay, let's not get this deep. But I think we should go like with what Italy says because that's what Italy teaches. So, you know. Anyways, let's continue. I think this is an exception also said. I don't know to be honest. I think this is like SFB is an exception. I don't know, let's not waste time on this and continue. So Perfect. Now, yeah, I want to give you some other things to memorize. They came on the talk exam, the last one of July. On July 30, there was a medicine exam in Italian. It was asked a question, and in the database questions, it was asked like 5 times about this. So let me just say it. So you should memorize sulfuric acid. Okay. So of the acids of phosphorus, okay, we have hypophosphoric acid, we have metaphosphoric acid, we have hypophosphorus acid, we have phosphorus acid. These for memorizing. So hypo is H4P2O6. Meta is HPO2. Pyro is H4P2O7. Hypophosphorus is H3PO2. Phosphorus is H2PO4. Okay. Phosphorus acid will look like this. Okay, and this will have like I guess in this way. Okay, so it will be looking like this. So here they might ask you, let's say any, not just phosphorus, let's say any other molecule that came in a way that looks like this, and it's not like just one like this or one like this, or I don't know. There was two central atoms, so here you divide them. Okay. And after you divide them, you just take first one, it's tetrahedral, second one is tetrahedral. So when you have a molecule that have two, you always divide them. Okay. You divide them and you work on one of them. Okay. Okay, perfect. So, is Angela, you texting me? Angela. Ah, okay. Yeah, this is what's killing me, that I'm saying something and they're against it, exactly. Okay, guys, I'll send you on the group something. Yeah, if you look at the 3D shape as a 3D structure, you will see it as a trigonal bipyramidal also. Yeah, what did I say? I sent you. Oh, yeah. I guess they are considering lone pair as an element, like you said for ammonia. Yeah, as I told you, there's something called resonance. Like when you have two electrons together, they make a lone pair. They will start affecting the other elements around them, and then they will create as an element. They will be considered as a full element, you know. So I guess that's why. Because like like I don't think a book will make a mistake, you know. Okay. So we were no, it's two. Okay, it's 2PO4 minus. It's an anion. It's not phosphorus. He will not speak about acid. Yeah, acid. Okay, it's H3PO4, PO2, H3, PO3. Because the hypo always takes one oxygen. Okay, here we have the hydrogen ion. Okay, let me delete this. Because this is an ion. Okay, so these are for memorizing. They were asked on the TOEIC exam. However, when you have an element which is like big like this, you divide it and you work only on one part of it. Okay, now what time is it? 8. We started on 6, 6 to 7, 7 to 8 after hours. We still have 1 hour. So, okay, guys, do you want this hour to be biology or chemistry? Okay, let's see where do we have more gap in the middle. Okay. Let's study some thermodynamics. So at least we'll be able to, go through thermodynamics faster. Oh my God. Okay. So we have We have four laws of thermodynamic, but we have to study for the IMAT only the three laws of thermodynamic. The zeroth law, you should not know it. So the first law of thermodynamics. So يلا dynamics. The first law says energy can be converted from one form to another, but cannot be created or destroyed. So energy can be transformed, but cannot be created or destroyed. So the first law. Okay. Okay. So energy this first one. Second thing you should know is that the total energy of an isolated system is constant. Okay, it's the sum of all other forms or all the forms of energy within the system. Okay. So energy can be converted from one form to another, but cannot be created or destroyed. The total energy of an isolated system is constant, and it's the sum of all the energy in the system. Second law of thermodynamics. Heat cannot be spontaneously. So heat cannot flow from a colder location, from a colder location to a hotter. Okay. And the entropy of an isolated system. If you remember, we spoke about the entropy, which is the delta S. Okay, not in equilibrium. Will tend to increase over time, approaching a maximum value of equilibrium. Okay, and so this is second law. Okay, and now the third law. Entropy, as we said before, and we spoke about it before, that it's the randomness of this system. So third law. Okay, so the third law says as the system approaches absolute zero, the entropy of the system approaches a constant. Yes, Judy? 0. Another thing, it is impossible to reach the absolute 0 of temperature through a finite number of operations. Let me make it more clear, all of them. So the first law says, and let's speak about the third law. As the system approaches absolute 0, the entropy of the system approaches a constant. Usually this constant will be 0. Let me explain them as formulas so it will reach you easier. So the first law formula delta U equals Q minus W. Delta U, what is delta U? Is the change in internal energy of the system. Q is the heat added to the system, and W is the work done by the system. Second law, that the entropy, delta S, is bigger or equal to Q over T. Delta S is the change of entropy of the system, Q is the heat added to the system, and T is the absolute temperature of the system in Kelvin. Okay, how to... Okay, then third law. S equals to 0 at T equals to 0 Kelvin. S is the entropy and T is the temperature. Other thermodynamic laws other than these three, we have PV equals to nRT for the ideal gas. We spoke about it before. And the most important one for the whole chemistry is delta G Gibbs free energy equals delta H, the enthalpy difference minus temperature times the entropy difference. Here, when we have delta H negative, delta G negative, Gibbs free energy is negative, delta H is negative, delta S is positive, entropy is positive, and the system is spontaneous. Delta G is positive, delta H is positive, delta S is negative, it's non-spontaneous. Here it's exothermic, here it's endothermic. Yeah. Now, these are kind of formulas you should know for the thermodynamics. Thermodynamics is not really easy. You should just use these formulas. They will give you, let's say, delta U. They might give you, until you can't find the work, they will give you like one of these two. It's a kind of so super easy concept in the IMAT. Yeah. So the things you should know for the IMAT. So I want to speak about perfect. I want to speak about the graph of CO2 and the graph of water. Okay. So draw the graph showing the dependence of the vapor pressure of a liquid on temperature. Okay. So first we have the graph of water. This also to memorize. Okay guys, one moment. Yalla yalla. 1 second guys. Okay. I'm sorry, guys. I had to go because I'm sick. So someone got me medicine. Okay. So we're speaking about the graphs, the graph of water and the graph of carbon dioxide. So this graph show us the relation between the vapor pressure or no, the relation between the pressure and the temperature. Temperature is always on the x-axis and the pressure is up. So the pressure when we are drawing the graph of water is in millimeter. No, should we? Oh my god. Okay, and temperature in degrees Celsius here, and here we're gonna have the temperature, and here we will have atmospheric. So here we will have the liquid phase, here we will have the solid phase, here the gas, here the liquid, here the gas, here the solid. So this is called the triple point. What does triple point mean? That now this element is in the three states coexisting together. Coexisting in the solid and liquid and the gas together. Here the same thing. Just should know that the triple point for the water is 0.01 at temperature and 4.58 on pressure. This you should like what you should know from the whole graph is this too. And however, for CO2, you should know that the triple point is at 5.1 atmospheric pressure, and temperature is minus something, minus 58. Yeah, and yeah, that's all you should know for these two. I think you should just memorize the values here. Okay. Now let's speak about the boiling point, the triple point, and the critical point. So these definitions also you should know. So the boiling point of a liquid is the temperature at which its vapor pressure is equal to the pressure of gas above, to the pressure of gas above it. Okay. Normal boiling point is the temperature at which its vapor pressure is equal to 1 atm. 1 atm pressure, why? Because it's a normal conditions. Or 760 torr, or 101.3 kilopascal. Yeah. So this is the boiling point, and of course the boiling point. Let's say we have two compounds, and we want to know if they have the same boiling point. If these two compounds you dissolve them or you dissociate them, and both of them give the same amount of molecules, this means that they have the same boiling point. Okay. Now we're gonna speak about the triple point definition. So triple point is the one that I showed you on the graph now. Temperature and pressure combination. At which temperature and pressure, okay, solid plus liquid plus vapor phases of pure substance can coexist in equilibrium. Okay. Critical point. Okay. So a point on a phase diagram, like the diagram that we just drew, at which both the liquid plus gas phases of a substance have same density, the liquid and the gas, okay, and thus indistinguishable, cannot distinguish between them, okay, between them. And thus another definition for the critical point has two definitions, is the highest temperature and pressure at which a pure material can exist in vapor or liquid equilibrium. Liquid equilibrium. Okay. Another thing you should know as a note here, that a temperature higher than critical temperature, the substance, let me write it again, cannot exist as a liquid no matter what's the pressure. So at a temperature higher than the critical temperature, the substance cannot exist as a liquid no matter what's the pressure. Okay, what is the critical temperature or the critical point? It's the point where both the liquid and the gas phases of the substance have the same exact density and super indistinguishable between each other. And it's the highest temperature and pressure at which this pure material can exist and can coexist between the vapor and the liquid phase equilibrium. However, if we have a higher temperature than this critical temperature, no matter what is the pressure, this substance cannot be a liquid, cannot exist as a liquid. Okay, this as a note. Perfect. Okay. So now other things you should know. Okay, we spoke about thermodynamics. This is not for the IMAT. I think everything else in the general chemistry is no more for the IMAT. Yeah, everything else is not for the IMAT. And there's another thing which is for the IMAT. Let me explain it. So, so we have in the periodic table both the nonmetals and the metals. Let's start with the reactivity of metals. So we have to memorize them. Reactivity of metals. K, it's an axis, you should memorize it. KNaLi. We're starting from the high reactive to the low reactivity. So yeah, other than the reactivity, we should also, yeah, today we have so much to do, to be honest. Anyway, so KNaLiBaSr. If you see, all of them are from the first group. As we spoke about it, it's very high reactive, the alkali metals. So CaMgAl, M and Z and CrFe, cadmium, then cobalt, nickel, tin, lead, hydrogen, antimony, bismuth, K, and then Cu, then Hg, Cu, mercury, and then Au, silver, and platinum. Okay, we start from the very highly reactive to the low reactivity. So here we have high reactivity. Here we have low reactivity. We can, if you want, divide them from K until Ca. These ones, they react with cold water. So they are highly reactive with cold water. From Mg, you can take it to stop at Pb, all of this. They react with acids and hot water. So here they react with acids, that's hot water. And then hydrogen, it's just included for comparison. So it's not really important in this axis. So included for comparison. And then all of these from Cu until down, these are highly unreactive. This is for the metals. Yeah. Hydrogen is not a metal, guys, but we put it here for comparison. Okay. Like to be able to divide them. Okay. So depending on these, we know if they are reactive or not reactive. The metals, I mean. Yeah. Okay. طيب. Now, for the nonmetals, we cannot really know. For the nonmetals, the reactivity of the nonmetal, it just depends on the bond formation, on the ionization energy, on the electron affinity, on the oxidation state, on the electronegativity. However, for the metals, you should memorize them. Okay, there's another thing you should also know about chemistry. You guys, do you need any break or are you okay or tell me? Yeah, we still have only 30 minutes. So tell me, is everything okay with you guys? Do you need any break? Anything else? Okay, all good. Okay. Yeah, because the most reactive metals are these. Um, like this is the series that will be asked on the IMAT, to be honest. The most metals which are reactive are the first two groups, alkali and alkaline. Yeah. Now I want to speak about something also in the chemistry. So first I want to write some acids, some bases. Okay. So let's speak about the strong acids and strong bases that you should memorize for the IMAT. So why am I asking memorize so much? Why? Because IMAT is a kind of very fast exam. If you didn't memorize, even if you try to guess or you have a way to guess, you really like need the more you memorize, the more you make the exam easier and faster on you. So you give this time to other things to be solved and calculated, you know. So that's why I always say memorize as much as you can from the IMAT for the IMAT. So we have strong. Hi. Hydrogen with halides and halogen are like one of the strongest acids. Of course, only with fluorine it will give a weak acid. So Hi, HCl, HBr, HNO3, HClO3, HClO4, H2SO4. These are strong acids, especially this one, this one, this one, this one, this one. These are super strong. However, the weak acids are HF, H2SO3, HClO hypochlorite, HNO2, the acetate one, so HC2H3O2, H2CO3, and cyanide, HCN, and HCOH. Metanoic, no. Okay. Clear. These strong acids and the weak acids. Now you are asked about these. Okay, these are asked for the IMAT. However, the weak bases are not asked for the IMAT. Strong bases are asked for the IMAT. So we're gonna study the strong bases. wrong. Add IOH, NaOH, KOH, CaOH2, SiOH2, BaOH2. How this reaction happens? Usually it's Ca2 plus, OH minus, criss-cross method. This goes down, this goes down. It becomes CaOH2. You know about this criss-cross method? They might get you a question on the IMAT that which one might seem wrong. So you will, like, they will give you molecules like these, and they will tell you which one might seem wrong. So you have to divide them and to see the oxidation state of each or the charge of each molecule. And then try to do the crisscross. If the crisscross didn't work, it will be wrong. It came on the TOEIC exam for this, the last one. Okay. Perfect. Now, spoke about acids and bases. Now I want to speak about something. Yeah, some things that you should know. The medium before you go to the IMAT. Okay? So you should also write them. Acidic things are acidic elements, ions, acidic cations, let's say. So the acidic things you should know for the IMAT are NH4 plus, Al3 plus, Pb4 plus, Fe3 plus, Cu2 plus. Basic F minus, NO2 minus, SO3 2 minus, C2H3O2 minus, Cn minus, CO3 2 minus, H minus, OH minus, O2 minus. Okay. Neutral, Cl minus, Br minus, I minus, NO3 minus, SO4 2 minus, ClO4 minus, Na plus, Li plus, K plus. These you should know for the IMAT. These are so important for the IMAT. Okay. Why they are important? Because they might ask you these questions. Let me tell you how. They might tell you, AlBr3, is it acidic or basic or neutral? If you already memorized this, you will find out that Br is neutral and the Al is acidic. So if you put acid with a neutral, who will dominate the acid? So this is acidic. You know how? They might tell me NaF is what? You will see Na is neutral, F is basic. Who will dominate the basic? So NaF is basic. Let's say they might get KNO2. K is neutral, NO2 is basic. So KNO2 is basic because basic dominates on the neutral. NaOH, of course, this is basic. So how should you know these things? You should just memorize this here, this chart, and then anything that comes, you already know everything. You see what dominate. Acidic dominate the neutral, basic dominate the neutral. You will never see acidic with basic, never. So always these two dominate the neutral, acidic and basic. Okay, what else? Just try to delete these. طيب. Now, okay, we did so good today, to be honest. We were so fast in the We're so fast in the course. So happy from this. Okay. Now I want to try to solve something that came on the IMAT. So let me try to also solve it. It's about the isotopes. Okay, we all know what does isotopes means. They have the same number of, the different number of neutrons, same number of protons. These are the isotopes. Okay, so where's the pen? I don't have in my hand. Okay, fine. Okay. طيب. This is the Lebanese word sad. طيب. Angela tells you. Angela, tell him طيب. Okay. So. Okay. Really? You live in Qatar? You know the word Habibi? Habibi come to Dubai? So we want to speak about stable isotopes. Okay. Yeah, طيب means good. It means good, it means delicious, it means everything. We Lebanese, we use it for everything you want. So, let's go back to the lesson. So, the stable isotopes. So, let's say a question came. Let me remember if it's the IMAT or no. Yeah, it's the IMAT. And it was like this. And now I tell you how to solve. It's about the stable isotopes. So, what did the question say? It said we have B2H6. And they said we have the isotope of boron 10 and the isotope of boron 11. And they said in the question, they gave us a hint and they said there is no isotopes for hydrogen. So they said hydrogen has no isotopes. Why? Because they want us to stay working on this hydrogen and just work on these two new isotopes. So they said that the isotope of B10 exists in air or exists only in 20%, not so much. And B11 exists more, 80%. And they told us, give us the ratios of these isotopes. And then it was like options, ratio options, you know? So the ratio options were like 142, 162, 1816, 2, 242. These were the options. Not these, but like it used to be looking like this. So how can you solve a question like this? So easy. Let me delete the options so we know how to solve. So first you have to draw a chart. Do this, do this, do this, and do this. And then you come here. How many boron do we have? We have 2. So it can be these 2. The hydrogen is the same. We won't change. We won't speak about the hydrogen. We won't even like touch it. Why? Because it's only isotope. So we have to focus on the boron. We look at the B. We have 2B. It either can be 10 or can be 11 or can be 10 10 or can be 11 11 or can be 11 10 or can be 10 11. So this B2 here, it can be a 10 10, like the 10 10 isotope. Both of them can be 10. Or the first one can be 11, the second is 10. or the first one is 10, the second is 11, or the first one is 11 and the second one is 11. So if you see here, we have 10, 11, 11, 10. So which is the same one. So we can do these together, calculate them together, you know? So the first one, which is 10, how much do we have 20%? So we put here 0.2 times, also 10, so times 0.2. 11, 10, 0.8 times 0.2. And here we have also the same 0.2 times 0.8. For both of them, it gives us 0.32 here. Okay. And here we have 0.8 times 0.8. Why? Because 11, 11. 80%. Here you divide by 100, of course, because it's a percentage. So if you multiply, you'll find out here 0.04, here 0.32 for both of them. Why we added them together, or we worked on them both together? Because we have the same 10, 11, or 11, 10. It's the same. It can be the first one or the second one. And here we have, it's like we're working probability in math, you know. And here we will end up with 0.64. And then we multiply by 100. We will end up by 4, 32, 64. And then in the options, it was 1, 8, 16. So what did we do? We just divided by 4 and it will end up by 1, 8, 16 for the three of them. And this was the correct option. Okay.
We have divide by the lowest number.
By the LCM, least common multiple. Like here we have the common one is 4. If 4 you divide it by 4, it will end up by 1, you know?
Okay, okay. And also this, I did not understand. This 10 becomes 0.2 and 11 becomes 0.8. I didn't understand this.
Yeah, you didn't understand why 10 is 0.2 and 11 is 0.8, right?
Yeah.
Yeah, because here the B10, the isotope 10 of the boron is 20%. You cannot put percent in the fraction. When you work as ratio, here we're working as ratio. This is over. This means divide, ratio. When you work as ratio, you cannot put 20. You have to divide it by 100 because
Oh,
percentage
okay,
is
okay, okay,
divided by
okay.
100. So you do it
Boron
like
10
this.
exists as 20% and boron 11 exists as 80%. Okay, okay.
Yeah, boron 10 is 20 and boron
Mm.
11 is 80. Okay. So this also came on the IMAT, and this is how a way to solve it. Okay. Now other things. Perfect. So another thing I want to say, yeah. Today you might finish the chemistry, guys. Okay. So now we're gonna speak about catalysm. I know you got bored. That's okay. Be bored, no problem. So catalysm or the catalyst. Let's work on this. So we have 2H2O2. Let's take this into consideration, this reaction. That makes 2H2O plus O2. Okay. So let's say we have the catalyst here. No, now the question is, what is the catalyst from this reaction? Perfect. So what did they say? They said we add I minus to this reaction, perform this reaction, and tell me what is the catalyst from this reaction. How do we know? Let's see. So we add an I minus, so H2O2 plus I minus gives H2O plus IO minus. And then IO minus plus H2O2 gives H2O plus O2 plus I minus. Okay. So then we do the overall reaction. The overall reaction will give us. So if you see here that the first one was, they gave us this, they gave us this, the question gave us this reactant H2O2, and they gave us another reactant which is I minus, and they told us perform a reaction to end up having this reaction. When you end up having this reaction, which one of these elements that we gave you, which one of these reactants, H2O2 or I minus, is the catalyst? Okay, so they gave us a shape of the end reaction, and they told us if we added H2O2 with I minus, what will we end up? We want to reach this product, this overall reaction, and from this overall reaction, we want to know which of these all, this or this or this or this or this or this, which one is the catalyst, you know? What is the definition of a catalyst? The catalyst does not appear, or it's not produced or consumed by the reaction. It just comes and accelerates the reaction. It makes the reaction fast. It's not, so if you see that there's something which is not consumed by the reaction, it's the catalyst. Perfect. So what do we do here? We look here and we add them together. We add this by this, and we will end up with these byproducts. We create them because you just do the addition reaction. And then here we use this one, the last one here, we still use it. We add water to the product, which is this. These two, we make from them another reaction, which is this one. Okay. So we using IO minus here, and using it again here, we creating IO minus here. I mean, we producing IO minus here, and then using it for another one, we will delete it. You understood why I deleted this? Because I produced it in the first reaction, but in the second I used it. So I don't care about it now. It cannot be in my overall, you know? So the overall will be H2O2. We put all the reactants before the arrow, all the products after the arrow. So H2O2 plus I minus plus H2O2 and this H2O2, okay, will give H2O plus H2O plus O2 plus I minus. Don't forget the IO minus, we deleted it because it's used. Okay? The anion which is produced always is used in the second reaction. Which reaction is slow, which reaction is fast? We will know at the end because they might ask you which reaction is slow, which reaction is fast. So at the end, I will tell you how to know. Okay? So, perfect. So now, here we're gonna have H2O2. Okay. So H2O and H2O, this means we have two H2O. H2O2, H2O2, we have two H2O2. Okay, and here plus O2 plus I minus. So, okay. Now we have, yeah, and we can do something. You should understand also something, that the moment that we have before the arrow any element, and we have the same exact element after the arrow, we can cross them. Let's say we have here H, like let's say here we have 6H plus, and here we have 14H plus, or 12H plus. We cross this 6 and we cross here, and we will keep here 6H plus. Why? Because 6 from here are used, so we just cross them. So you should understand everything before the arrow, we cross. If it's the same and after the arrow, you should cross them. So here, what do we have? The same I minus. So we cross the I, we cross the I. So which one do you think is the catalyst? The catalyst is I minus Y, because it's not used. It entered the reaction. Look at it. Yeah. It entered the reaction. It is inside the overall reaction, but it's not used or produced. It's not even used. It's not even in the products. It's deleted. So this means that we just use it to fasten the reaction. So the first reaction will always be slow. The second reaction will be fast. Okay? Why? Because we use this catalyst accelerated the reaction, but it's not used. Why IO minus? It's since IO minus didn't appear in the overall reaction, but it is produced and then consumed. The moment we heard the word produced and consumed, this means it's never a catalyst. The catalyst is never produced and never consumed. The catalyst is just used for accelerating the reaction. The moment we saw that this is produced with the products and then consumed again, this is no more a catalyst, although it's not showing in the overall reaction. So the overall reaction will be the same as up to H2O2 and to H2O and O2. The I minus is not here because we deleted it. So I minus is the catalyst. Do you have guys any doubts or you understood it or you have any questions? Everything is clear? So you should always, when they ask you about the catalyst, you should know, okay, how to find slow or the fast reaction. How did I know that the first is slow, the second is fast? So the first one, if you see the I minus, we here the question was, who is the catalyst? So since I minus is the catalyst here, it was a reactant or it was added. So the reaction was still slow. When it's at the end, it's shown at the end, so the reaction is fast. The reaction already is done and the catalyst already worked its work, so this means that the reaction is fast. Okay. Perfect. Anyone has any question? Okay, what did Sayed ask? How to know that we have, and no, tomorrow is Saturday. Saturday, Sunday, we don't have. How to know that you have to add, you and I, and the sad, or whatever as catalyst. How to know what is the catalyst, you mean? Like you're asking yourself, what is the catalyst? How to know, like how to add I?
I mean, they will give us in the question that you have to add this with the reaction and find with the help of this.
Yeah, the question says that we have H2O2, add I minus with it, end up with this reaction. They gave us the overall reaction and they told us add I minus, and then tell us which of these elements inside all of these reactions is the catalyst. And then they also asked which reaction is the slow, which is the fast. So when you see the catalyst, you see if it wasn't the reactants, means it's slow, it didn't work its work yet. If it's the product, it's fast. And how do you know that it's I minus? Here we have two options. It's either I minus or IO minus. Why? Because IO minus didn't show in the overall, and I minus also didn't show in the overall. So here, like students will usually confuse. It's maybe IO minus or I minus. But if you see that IO minus was used, was consumed and produced. So this means that it's not the definition of a catalyst. However, I minus was not used, was not consumed, was not produced. It was just there, and then we crossed it. It just disappeared. So this means this is the catalyst, you know? Okay, perfect. Now it's 9. We already did 3 hours. As I said at the beginning that everything solving, we left it for the end. I'm trying to finish the course as fast as possible. Okay? And have a good night. Tomorrow there is no session. After tomorrow there is no session. So try your best to solve past papers and try to do your assignments and have a good night.